Good afternoon, everyone. I am going to present to you our report, which is Pressure Measurement by Manometer. In Fluid Mechanics course, pressure measurement with different devices is much important. It is also one of the most important measurement in continuous process industries. And in our report, we will learn different pressure measuring devices. Let us define manometer. Manometer is a device used for measuring the pressure at a point in a fluid by balancing the column of fluid with the same column or another of the fluid. So when we say manometer, it is the most simple and precise device used for the measurement of a pressure. And ang manometer din ay consists of transparent tube constructed in the form of an elongated U. And makikita din natin sa picture ng manometer na U-shaped tube of glass siya, filled with some liquid. And yung liquid na yon is typically a mercury because of its high density. Sa tulong din ng manometer, we can measure comparatively high and negative pressure. And typical manometer applications also include measuring pipe fluid flows and a gas pressure. There are two types of manometer, the simple manometer and differential manometer. First is simple manometer. It consists of a glass tube having one of its end connected to the point where pressure is to be measured and the other end is open to the atmosphere. The common types of simple manometer are piezometer, U-tube, and a single column. The second one is differential manometer. These are the devices used for measuring the difference of pressures between 2 points in a pipe or in two different pipes. The common types of differential manometer are vertical single column manometer and inclined single column manometer. Ang simple manometer ay has only one liquid, while the differential manometer has two or more liquid. At ang simple manometer din ay nagbibigay ng direktang sukat ng pressure. Ang differential manometer naman ay ginagamit lamang when we need to know the difference between two pressure. Isang halimbawa nito is to measure the flow dynamics of a gas by comparing the pressure at different points in the pipe.
The first example of manometer is piezometer. A piezometer is simplest form of the manometer. It measures gauge pressure only. The pressure at any point in the liquid is indicated by the height of the liquid in the tube above that point, which can read on the calibrated scale on glass tube. So, dito sa piezometer, it measures a gauge pressure only. Gauge means panukat. Gaya ng ifa-flash yung picture na ito. So, piezometer measuring the pressure of a liquid or gas or something related to pressure. Tulad ng fluid piezometer ay madalas na inilalagay sa mga borehole upang masubaybayan ang presyon or pressure o lalim ng tubig sa lupa. Ito yun. This is the piezometer. Pressure is in the pipeline. This is the pipeline. One length of the piezometer is open to the atmosphere and the other is connected to the pipeline. Once we know the height of a liquid columns, we can easily find the intensity pressure inside the pipeline by using the formula of piezometer. For the first example, a pressure tube is used to measure the pressure of oil with mass density of 640 kg per cubic meter in a pipeline. If the oil rises to height of 1.2 above the center of the pipe, what is the gauge pressure at that point? With a gravity of 9.81 meter per square seconds. So, ang gagamitin nating formula is P is equal to PGH. So, ang ating P is equal is for pressure and G is gravity and H is height. So for the next is substitute. So, ang ating pressure is 640 kg per cubic meter and then height is 1.2 meter and ating gravity is 9.81 meter per square seconds. So, compute lang natin. So, P is equal to PGH and so, substitute P is equal to 640 times 9.81 times 1.2. So, let's compute. So, ang nakuha natin ay P is equal to 7.55 kilonewtons per square meter. Para mapadali ang ating pagsosolve, kailangan nating i-separate muna ang mga gagamitin natin sa pagsosolve. Gaya ng pressure, gravity, and height. Gaya nito. Ang ating second example is find the elevation of the oil surface in the attached piezometer. So, in this problem, kukunin natin yung pressure head manometer. So, ang ating air pressure is 35 kilopascals with the elevation of 2 meters and oil 0.83. In this equation, the pressure PF is the pressure exerted by the fluid inside the manometer only. If the piezometer is open to the atmosphere, then we must add an additional variable. So, ayun nga, yung ating tangke ay open to the atmosphere. So, mag-add tayo na isang variable which is yung water, yung nakabilog dyan. Yan yung inad natin na variable. So, HF or height of a fluid is equal to pressure of a fluid, pressure that exerted by the fluid and over pressure and gravity. At dahil nag-add tayo ng isang variable, ito ang gagamitin nating formula to solve the problem. PT is equal to PF plus P atmosphere. PT is equal to HF PG plus atmosphere. So, let's substitute. So, yung next naman tayo sa PT is equal to HF PG plus P atmosphere. So, PT is equals to yung height of a fluid natin is 2 meter which is our elevation. And then 0.83 yung ating oil. And then yung ating in-add na variable na water which is 9.81 kilonewtons per cubic meter plus 35 kilopascals. So, compute natin lahat yan. Multiply and then plus 35 kilopascals. So, yung nakuha natin is 51.2846 kilopascals. So, ito yung gagamitin natin para mamaya sa converting to pressure head. So, let's convert to pressure head. Ang ating formula na gagamitin is HP is equal to P over Y, which is HP ay yung pressure head, and then yung P is pressure, and then yung Y is specific weight. This formula uses two variables. So, yung two variables na yun ay yung pressure and specific weight, which is pressure is the force and Y is a specific weight. So, let's substitute. So, HP is equal to, yung P natin is yung answer natin kanina na 51.2846 kilopascals over yung specific weight natin na Y is 0.83 na yung oil natin and then yung water natin na 9.8. So, i-divide lang natin to para makuha na natin yung sagot natin, yung final yung pressure head natin. So, 51.2846 kilopascals over 0.83 times 9.8. So, let's divide. Ang nakuha natin is 6.3 meter. 3 meter yung pressure head natin. Yun lamang po.
A YouTube manometer. It can measure large pressure or vacuum pressure and gas pressure. A YouTube manometer in which differential pressure is measured as the difference H between the high pressure reading and the low pressure reading, multiplied by the density of the liquid in the tube. A YouTube manometer is used as an indicator that the fan of the mitigation system is working. A pressure gauge is an instrument for measuring the conditions of fluid, the liquid or gas, that is specified by the force that the fluid would exert when at rest on a unit area, such as pounds per square inch or newtons per square centimeter. Let us try to understand how to measure the gauge pressure using YouTube manometer. Here we have shown the YouTube manometer. This is the left leg of YouTube manometer and this is the right leg of YouTube manometer. Both these things, they are open to the atmosphere, so naturally at both the ends there will be atmospheric pressure that is attained. Now suppose we fill this YouTube manometer with L4 manometer fluid as shown over here. Now as the pressure that is acting at the both end is the atmospheric pressure. Therefore, the level of the manometric liquid that is present in the two legs or two limbs will also be the same. Now, suppose we want to measure the pressure of the liquid that is flowing through this particular pipe, and let's assume that the pressure of the liquid that is flowing through this pipe is higher than the atmospheric pressure. So when we connect the left leg to the pipe, then as the pressure of the liquid that is flowing to the pipe is higher than the atmospheric pressure, and therefore the level of the manometric liquid will go down in the left leg and will go up in the right leg. Let us assume that the pipe it is carrying the fluid whose pressure we want to measure is having specific gravity 5.1 and specific weight gamma 1. Similarly, the manometric fluid is having specific gravity H2 and specific weight gamma. Now, let's connect the level deck to the pipe so the liquid will enter inside the particular pipe in the left leg of the YouTube manometer from the pipe, and it will force the level of the manometric liquid in the left leg in downward direction, and the corresponding rise will be there in the corresponding rise of the manometric liquid will be there in the right leg. This K point is known as the gauge point, this XX known as the reference point. Now, from the center of the pipeline up to this XX, the pressure reading is H1, and from XX up to this level of the mercury or manometric grid, suppose the level is HD. Now we want to measure with the pressure at point 8, so we'll apply the pressure balance over here, so we can say that pressure above XX in the left leg is equal to the pressure above XX in the right leg. So in the left leg, we are having the pressure that is acting at point A, that is PA plus pressure corresponding this very H1, that is gamma 1 H1, because we know that the liquid that is present in the pipe length is having a specific weight of gamma. So gamma 1 H1, this is the pressure because of this particularly appreciated H1 is equal to pressure above X6 in the right limits. So here the liquid that is present is mathematical, at which specific weight is gamma 2. So pressure will be gamma 2 into H2 corresponding to this pressure wave plus. Here the liquid that is present is mathematical at which specific weight is gamma 2, so pressure will be gamma 2 into H2 corresponding to this pressure wave plus 0 because this limb is open to the atmosphere back at atmosphere gauge pressure is 0, so we can say that this is PE, that is pressure at K plus gamma 1 H1 corresponding to this grade H1 is equal to this gamma 2 H2. We have one example here. The density of the oil in the left is 790 kg per cubic meter, a height of 30 cm. The right side is filled with water. Calculate the height shown in the figure. So we want to find this value H, so go ahead and try this problem. Now, let's establish a reference level. Let's call the height H1 or rather H2 that is going to be the height of the water above the reference level. Just like before, we know the pressure of the oil exerted on the left side has to equal pressure of the water exerted on the right side. The portion that's above the reference level, and so that's going to be density times gravity times height. The density of the oil is 790 and the height of the oil is 30 cm. The density of the water is 1000, so let's calculate H2. So it's 790 times 30 divided by 1000. So H2 is 23.7 centimeters. How we're looking for this is which is the difference between 30 and H2. So H is 37 centimeters minus 23.7 centimeters. So the answer is 6.3 centimeter. So the surface of the oil is 6.3 centimeters higher than the surface of the water.
A fluid is flowing through a pipe and the pressure of the fluid inside the pipe is lower than the atmospheric pressure. A test vacuum gauge to monitor the pressure. See, for instance, the vacuum gauge that is attached to the pipe shows you 1000 pascals, means pascals, so this 1000 pascals is the vacuum pressure of the fluid at the pipe. So now, the question is, what does this 1000 pascal indicate? It shows that the pressure inside the pipe is such that it is 1000 pascal lower than the atmospheric pressure. So vacuum pressure indicate how much pascal is the pressure lower than the atmospheric pressure line. Again, the pressure can be represented from the absolute zero line, which is known as absolute pressure. So absolute pressure will be equal to atmospheric pressure minus vacuum pressure. Atmospheric is 1125 minus 1000 pascals. 38 is the absolute pressure going through the pipe. Now again, the equation can be used to convert the use of pressure from vacuum pressure to absolute pressure or vice versa. So the vacuum pressure, consider atmospheric pressure as the reference line and measure the pressure accordingly, but unlike the gauge pressure, vacuum pressure is specifically used for representing the pressure which are lower than atmospheric pressure value. The beauty of gauge and vacuum pressure, you can easily feel and realize the fluid pressure from their values as they are measured considering normal atmospheric pressure reference.
Today we will understand here the basic concept of single column manometer to measure a pressure at a point in fluid. So ano nga ba ang single column manometer? So single column manometer is a modified form, a U-tube manometer in which one is slide in a large reservoir and the other side in a small tube open to the atmosphere. There are basically two types of single column manometer on the basic of right limb of manometers. As mentioned here, number one is vertical single column manometer. Number 2 is inclined single column manometer. So, unahin natin yung vertical single column manometer. So, kaya siya tinawag na vertical single column manometer because the other limb of the glass tube will be vertical as shown in the figure. So, from the word vertical, kaya siya tinawag na vertical single column manometer. So, let us consider na meron tayong one container filled with liquid. And to measure the pressure of liquid at point A into container. Kaya kailangan natin gumamit ng pressure measuring device which is yung vertical single column manometer. So, here to measure the pressure of liquid at a point. Then, once na yung vertical single column manometer ay nakakonect sa container, ang mangyayari ay yung heavy liquid reservoir ay bababa dahil sa high pressure ng liquid at point A into the container. So, therefore, yung liquid will rise in right limb of the manometer.
Cross-sectional area here in the reservoir times the change in height or the delta H is equal to cross-sectional area of the tube times the height 2. Then we will get the pressure in the right limb. P equals density 2 times G times we have delta H plus H2 as the height. Then we will get the pressure in the left limb, which is P equals density 1 times G times the height is delta H plus H1. Delta H plus H1 plus the pressure here at A. Equating these pressures, we have density 2 times G times delta H plus H2 is equal to density 1 times G times delta H plus H1 plus pressure at A. So pressure at A is equal to density 2 G delta H plus H2 minus density 1 times G times delta H plus H1 equals delta H times density 2 G minus density 1 times G plus H2 density 2 G minus H1 density 1 times G. But from the equation, delta H is equal to A times H2 over A. So, substitute lang natin. Pressure at A equals A times H2 over A. Pinalit lang natin din sa delta H times density 2 G minus density 1 G plus H2 times density 2 G minus H1 times density 1 G. Ay, hindi na pala kita. Ayan. So, dahil yung A naman is very large as compared to yung A na cross-sectional area nitong reservoir is very large as compared to the cross-sectional area ng tube. Yung ratio natin na A over A will become very small na pwede na siyang i-neglect. So magiging ang formula na lang natin ay PA equals H2 density 2G minus H1 density 1 G. Kasi maneneglect na natin tong part na to. So, ito na lang yung final formula natin para dito.
Inclined single column manometer. What is inclined single column manometer? An inclined manometer is a slightly curved tube with a liquid inside, typically a form of oil mixture. Inclined manometer is employed for the measuring of tiny pressure and observed a lot of accuracy than the vertical tube kind manometer, because of inclination, the gap affected by the liquid in a manometer. The purpose of inclined manometer is essential for retaining the most accurate pressure levels for industrial gas applications. Inclined manometers are typically used to measure liquids and gases where the pressure is very low. At this discussion, we are going to find out the expression at finding the pressure P in case of inclined single column manometer. Inclined single column manometer is more sensitive, more accurate, and very small pressure can be measured. Today, we will understand here the basic concept of inclined single column manometer. With the help of this example, we fully understand the equation of inclined single column manometer.
So we need to do what? We have to introduce this left L. So for this, what we have to do, we have to understand the concept of trigonometry. So let's say this is L, we use this better. Yeah. Let's say this is what L. This is angle what theta. This is what H2. Now I hope you understand. So this is a kind of right angle triangle. So we can use the concept of trigonometry. That is what we know. P upon x is equal to sin theta. Here what is the P? P is x2 and here what is x, that is L, is equal to sin theta. Therefore what we can write, x2 is equal to L sin theta. Now in the place of x2 we can write L sin theta g minus 1 x1 g, and this is dv. Alright, so this is the expression for finding out inclined single column manometer.
Differential manometer are devices used for measuring the difference of pressure between 2 points in a pipe or in 2 different pipes. It consists of a tube containing a heavy liquid whose 2 ends are connected to the points which difference of pressure is to be measured. So this differential manometer has 2 commonly types. These are U-tube differential manometer and inverted U-tube differential manometer. U-tube differential manometer. It is used to measure pressure difference at 2 points in a pipe or between 2 points at different levels. A U-tube differential manometer consists of a glass tube bent into a U shape, wherein the 2 ends of the U-tube are connected to the point whose pressure is to be measured. Then, a U-tube differential manometer is a type of a differential manometer which it is used to measure the difference of pressure between the 2 points of the pipes, that it can be in same level or in different level. Case 1. U-tube upright differential manometer connected at 2 points in a pipe at same level. So, there is an equation there. Let S is equal to the specific gravity of liquid for which pressure has to be determined. S1 is equal to the specific gravity of manometric liquid. HA is equal to pressure in terms of height of fluid in the pipe at point A. HB is equal to pressure in terms of height of fluid in the pipe at point B. H is equal to the distance of mercury level in the right limb from the datum line XX. H1 is equal to the height of manometric liquid level in the right limb from the center of pipe at point B. So here is an example. A differential manometer connected at the 2 points A and B in a pipe containing an oil of a specific gravity of 0.9 shows a difference in mercury level as 150 mm. Find the difference in pressure at the 2 points. Our given here in problem 1 is the specific gravity of oil, which is 0.9, our manometric liquid, which is 13.6, and our distance of mercury level, which is 150 millimeter. So the unknown is PA minus PB. The formula is HA minus HB is equal to H times the quantity of S1 minus S. Solution. Using our formula, HA minus HB is equal to H times the quantity of S1 minus S. So, ang gagawin lang natin is isa-substitute natin yung corresponding value nila, which is 150 mm times the quantity of 13.6 minus 0.9 is equal to 1,905 mm. So, yung 1,905 mm, i-convert natin siya into meter. So, we will divide it by 1,000. So, 1,905 divided by 1,000 is equal to 1.905 meter. Now, using the relation to get our pressure, we will use the formula PA minus PB is equal to W times H. Our W there is the specific weight of water. So, we will substitute with their equivalent value. So, 9.81 kilonewton per cubic meter times 1.905 meter is equal to 18.69 kilonewton per meter square or 18.69 kilopascal. Case 2. YouTube upright differential manometer connected between 2 points at different levels and carrying different fluid. So there is an equation there how to get the right limb, left limb, and the pressure at same datum line. Let S1 is equal to the specific gravity of liquid in pipe A. S2 is equal to the specific gravity of liquid in pipe B. S is equal to the specific gravity of manometric liquid. HA is equal to the pressure head in terms of height of fluid in pipe at point B. HB is equal to the pressure head in terms of height of fluid in pipe at point B. H is equal to the distance of mercury level in the left limb from the datum line XX. H1 is equal to the height of manometric liquid level in the left limb from the datum line XX. While H2 is equal to the height of manometric liquid level in the right limb from the center of pipe at point B. So here is an example. Figure shows a differential manometer connected at 2 points A and B at air pressure of 100 kN per cubic meter. Find absolute pressure at B. Our given here is the pressure head at A, which is 100 kN per meter square. So, i-divide natin siya with the specific weight of water, which is 9.81 kN per cubic meter. So, it is equal to 10.19 meter. Then, our manometric liquid, which is 13.6, then the specific gravity at B, which is 0.85. Our unknown here is PB. So, our left limb equation is HA plus H1 times S1. So, yung H1 natin is 650 mm. So, convert natin siya into meter. So, 650 millimeter divided by 1,000 is equal to 0.65. Plus, our HA there is 10.19. So, 0.65 plus 10.19 is equal to 10.84 meter. Our right limb equation is HB plus H2 times S2 plus H times S. So, first, i-convert muna natin si H2 tsaka H. So, our H2 is equal to 250 mm divided by 1,000 is equal to 0.25 meter. Then, H is 150 mm divided by 1,000 is equal to 0.15 meter. So, HB plus 0.25 times 0.85 plus 0.15 times 13.6 is equal to HB plus 0.2125 plus 2.04. is equal to HB plus 2.25. So, para makuha natin si pressure head at B, kailangan natin gamitin yung equation ni left limb tsaka right limb. So, yung value ni left limb is 10.84 is equals to yung value ni right limb which is HB plus 2.25. So, HB plus 2.25, i-transpose natin siya sa left side. So, magiging negative siya. So, 10.84 minus 2.25 HB is equal to 8.6 meter. So, para makuha natin si pressure at B, kailangan natin gamitin yung formula na PB is equal to W times HB. So, yung W is 9.81 kN per cubic meter times our HB is equal to 8.6 meter is equal to 84.36 kN per meter square or 84.36 kilopascal.
Next is the inverted U-tube differential manometer. It is used for measuring the difference of low pressure between 2 points. In this manometer, we use lighter liquid instead of heavier liquid. Kasi sa U-tube differential manometer, mas preferred nila yung heavy liquid like mercury. Dito naman sa inverted U-tube differential manometer, mas preferred ang light liquid like oil. Also, accuracy is the main characteristic of this type of manometer. As we can see, we have an equation here. Let's see the picture of inverted U-tube differential manometer. The X is the datum line and that is the light liquid. Let S1 the specific gravity of liquid in pipe A, S2 a specific gravity of liquid in pipe B, S a specific gravity of light liquid, H is the difference of light liquid level in the U-tube, H1 height of liquid level in the left limb below the datum line, H2 height of liquid level in the right limb below the datum line, and point A represent HA, point B represent HB. Example, an inverted differential manometer is connected to two pipes A and B carrying water under pressure as shown in figure. The fluid in manometer is oil of a specific gravity 0.75. Determine the pressure difference between A and B. Given specific gravity of oil, S is equal to 0.75 and the S1 and S2 is 1. Difference of oil in the two limbs is 450 plus 200 minus 450 is equal to 200 millimeter. Let's convert it to meter. It's 0.2 meter. H1 and H2 is 0.45 meter. Let's compute the pressure head in the left limb below the datum line. The formula is HA minus H1 times S1. HA minus 0.45 times 1 equals HA minus 0.45. So, let's compute the pressure head in the right limb below the datum line. Formula HB minus H2 times S2 minus HS equals HB minus 0.45 times 1 minus 0.2 times 0.45 is equal to HB minus 0.6. We will now determine the pressure difference. HA minus HB is equal to 0.15 meter. Now, using the relation P is equal to W times H, which means the W is the weight density of water and the H is the difference of 2 points. Weight density of water is 9.81 kilonewton per cubic meter. So, 9.81 times
0.15 is equal to 1.47 kilonewton per square meter or 1.47 kilopascal.